In this video, we are going to talk about the projection of one vector on the other one. So the idea is basically this. We have two vectors, say vector u and another vector v. Alright? So the projection of u on v will be, well, it is something like checking the shadow of the vector. I mean, we are going to have the projection to be here on v. It's up to this part. Okay? So it is like if you give light from the top to the vector u, the shadow on v will be like that. It will be on here. That's the idea. So this is called as the projection of u on v. That's how we show it. And the formula for it is the dot product of the vectors u and v divided by the square of the magnitude of v, and this is multiplied by the vector v. So this means here we get a scalar value. Oops. A scalar value, alright? So we multiply the scalar with the vector v. Now, the idea here is that the scalar here we calculate is probably between 0 and 1, so that it will be shorter than the actual vector v. Alright? So, here we multiply the scalar with the vector so that we find the actual projection. We are calculating this projection so that the angle in between here is 90 degrees. So, if we have this vector, let's name it like W1, and if we tend to have here another vector called as W2, then W1 and W2 will be orthogonal. Why? Because the angle in between those vectors will be 90 degrees. Hence, in the question, if it asks you to calculate the projection, you're going to use the formula. Then, if it asks you to find a vector so that the projection, which is actually W1, and that vector we will find, which is actually W2, will be orthogonal, then we are going to go through like this. I mean, V1 plus V2 will give us the resultant vector u. So it will be W1 plus W2, will be u. So if we know W1, where? From the projection, and we know the u, because u will be given in the question along with v, then what we're going to do is we will subtract W1 so that we will have W2 to be u minus W1. So this will be your second vector. Okay. So we have this formula for the projection, which actually is also W1. And then to find W2, we use the vector operations so that we find the other vector, which is orthogonal to W1. Let's see the example. Okay, in this question it says find the projection of u onto v, and then write u as the sum of two orthogonal vectors, one of which is the projection of u onto v. Well, actually, we don't need this part because we know that one of them is the projection. So, first of all, we will calculate the projection according to the formula. Here, So the projection of u on v will be the dot product of u, let's substitute u, 3 to 2, dot 5 to minus 5, divided by the magnitude of v squared. So it will be the square root of, well, v is 5 and minus 5, so it will be 5 squared plus minus 5 squared in a square root, and then it says the square of the magnitude, so it is a square here. So when we simplify, we get the following. So 3 times 5 is 15, plus 2 times minus 5 is 10, minus 10, so it makes plus minus makes minus. It will be 15 minus 10. Divided by, well, here, this square cancels the square root here, so we don't have any square root anymore. 5 squared will be 25, plus minus 5 squared will be 25. So of course, I forgot. There is this v here, we have to write it here. We have to multiply with the vector v. So actually it will be, let's write 5 to minus 5. Alright, so there is this multiplication. And here, after that, we have, okay, let's write like this, times 5 to minus 5. Okay, it will be, well, here it is 5, and here it is 50. So 5 and 50 simplifies out to 1 over 10. So if we multiply the vector with the scalar, we will get 5 over 10 to minus 5 over 10, which we can simplify to 1 over 2 to minus 1 over 2. Now, this is the projection of u on v. This is actually another vector, which is also called as w1. So let's clean it for the second part. Okay, let's see this on the graph to figure out what's going on. Actually, we don't need to graph this because the question doesn't ask us to graph, but, well, it's better if we draw a graph for this one. So in the graph, we have u and v with red, and the green small vector here is our projection vector. Now, and here I draw this dotted green line, which I'm now drawing with orange. The dotted line with the projection vector has a perpendicular 90-degree angle. Now here, so I can say that this projection vector can be named as w1, and here this vector can be named as w2. So this will be the vector we will try to find, so that w1 and w2 will be orthogonal vectors, which sums up to the vector u. So what we are going to do is, as in here, we are going to write u to be 3 and 2 equals, well, what is w1? It is 1 over 2 to minus 1 over 2 plus w2. Now, if you have this here as minus, it will be 3 to 2 minus 1 over 2 to minus 1 over 2. So we will have w2. When we calculate, we will find 3 minus 1 over 2, it will be 5 over 2, to 2 plus, because minus minus here will give you plus, 2 plus 1 over 2, you will again get 5 over 2. So this is our second vector, which is orthogonal with our projection vector. That's how we find it. Now is your turn. It is the same question with different vectors. Please solve the question and enter your answers in the answer sheet.